Hello, my name is Joe Hammes and I am the owner of Centennial Technologies. We are a full-scope machine design and build company located in Saginaw, Michigan. We offer robot integration and we have a partnership with Mitsubishi Electric. We value our relationship with Mitsubishi because they offer a full spectrum of control system components. That allows us to provide full systems for our customers that have the flexibility to meet all of their exact requirements. Thank you.
I'm John Nelson. I'm the automation manager of Centennial Technologies. I head up all the robotics projects for us, and one of our focuses currently an injection molding machine cell, which is what we built this demo for, to show you the capabilities of the Mitsubishi RV7 robot as one example. This is a middle of the road reach robot for what we have to offer. But the concept here is to be able to show a smaller injection molding machine, mostly 300 tons and under, that we can adapt a 6-axis robot to. This system is very compact, very flexible, and it's a nice package to automate your injection molding machine systems. Compared to the old style automation, we're going with a new style approach, small, compact 6-axis robots. We do some things with a 45-degree mount on the end of arm tool, which allows the robot better access when it comes into the side of the molding machine to keep the wrist at an advantageous position to allow you to get the parts out of the machine. The 6-axis robots like this work very nice because they have a lot of flexibility into the overall design of the wrist assembly as far as moving the tool to get it out of the molding machine. And also they're a very rigid assembly, so there's no flexibility in the robot arm, which also allows you to get the parts out of the machine better. This particular robot series from Mitsubishi has a nice valve package, as you see here, mounted right in the arm. The valves are internal, keep them away from any debris or contamination. And the end of arm tool system has a nice quick change chuck design from our friends at SAS Automation that help us out with the tooling and do a good job. And the robot in general is basically here along with, this would be a mounting base that would bolt onto your injection molding machine with mounting holes that are on the top of most machines. And so it's a very simple package that gives you a lot of flexibility to work with your products. And we'd be happy to look at any application you have and come up with a package like this for your company.
With our HMI controller, our GOT controller, we are able to disconnect the teach pendant, and we have all the controls that you would normally have on the run screen of the teach pendant. From the screen I can select programs, I can turn the servos on and off, start and stop programs, reset airs, and also change the speed. This allows for easy, full control of the robot system without the need to have the teach pendant. I'll demonstrate turning the servos on, and we'll go ahead and we'll start the program. The robot now is running. You can see that the program is running through the line numbers. It's showing you which line number we're on in the actual robot program code. We can change the speeds here by adjusting the speeds up and down. I can either use the arrow keys to adjust the speed up and down, or I can key in a new speed. Inside our control panel we have the PLC controller located here on the bottom. What this allows us to do is we have the PLC controller as the controller for the entire system. This PLC would allow us to add I/O cards to control peripheral devices such as bowl feeders, conveyors, anything that might be part of the entire package for the injection mold machine. Also included in our control package is safety relays. These safety relays would be used to interface with the injection molding machine. This is the SPI interface used to handshake between the injection molding machine and our controller for emergency stop situations. We are able to utilize all the standard functionality that would be part of the PLC and GOT system. Part of that would be recipe management and alarming and everything that is part of the GOT system. So as an example here, I'm going to open this door during operation. The robot is stopped immediately, and the system knows and can alarm the operator that the door was open. You can close the door. You're allowed to reset the airs from the GOT and turn the servos back on and restart the program. Also, as part of our control box, since this is a standard PLC, we can add on any type of I/O configuration to the system, either local I/O cards to the PLC and also remote I/O.
This is RT Toolbox 2, Mitsubishi's simulation software. I can open up an existing workspace that I've already created. Go online with the simulator. Expand the view. There's a drop-down window where you can manipulate it around, or you can pull on the screen by orbiting it. I can zoom out. Basically, this allows you to choose the proper robot for your application as far as reach and stature. Once I have my program in here, this is online. I can open it up. I can view it. I can make changes just as if I was in the robot teach pennant, programming and typing in code. It's a lot faster in here. I open it in debug mode. You can change your panel layout to a double horizontal panel or vertical panel. And I can actually run the job, and it runs you can see it running through the job, and it does the same thing that the live machine does.